This is a video for the SLO problems. We call it the SLO problems to shorten it. This is for problem 1. Here it is. It's from the material in section 1.8. You don't have a problem exactly like this in my math lab, but the principles are all there. We have the height S in feet at time t of a silver dollar dropped from the top of a Washington monument is represented by this equation. And we want to find the velocity of the dollar when it hits the ground. So what we want to do is we want to, let me get a pen working. We just want to kind of keep in mind what we're referring to. So here's the Washington Monument. A silver dollar is going to be dropped, just dropped down, and we're wondering, okay, when it hits the ground down here at the bottom, when it hits the ground down here, what is its speed? Of course, you know, we're talking about speed as the velocity. That's what's going on. And the way we do this, there's two things that we need. We need the first derivative. The first derivative always gives us our velocity. And the second thing we need to know is we need to know time for when it hits the ground. Both are pretty simple, and then we to find, and then we will just combine these two. So first thing, S prime, that is negative 16 times the derivative of t squared, which is 2t, so that's negative 32t. And when it hits the ground, S of t is 0. So we can say 0 is negative 16 t squared plus 555. I'm going to bring this over, and it's going to change signs. Divide both sides by 16. And then to get t, we take the square root, which means we have plus or minus the square root of 555 over 16. Now this is going to give us our exact answer, and really we're just looking for the positive of it. We don't need the negative of it. And what we're going to find is that this is 5.890, just rounding to the thousandths place. Now this is in seconds. Now when we plug it into the first derivative, we then will actually get our actual speed. And this will be in feet per second. So when you type this in, you're going to get negative 188.48. And this is what we're looking for. The negative is there because it's going down toward the Earth, and but this is the speed in feet per second.